Imagine looking through the forward window of a spacecraft and seeing two suns, not rising, not setting, but spiraling toward one another. This is Nathan's mission, and this is what happens when stars collide. His ship is called Icarus 7. It has crossed the dark between worlds for 11 months, carrying one pilot, a library of instruments, and a question no human has ever watched unfold from this close. Nathan is not chasing a planet. He is not searching for life. He is following a signal from a binary system where gravity has turned two dead stellar cores into a cosmic clock. Every orbit is shorter than the one before it. Every pass steals a little more energy. The system is whispering in gravitational waves, ripples in space-time that travel outward at the speed of light. The two objects were once massive stars. Long ago, each died in a supernova. What remained was a neutron star, a city-sized sphere with more mass than the sun packed into an unimaginable density. A teaspoon of that material would weigh roughly 1 billion tons on Earth. Yet these objects are only about 20 kilometers across. They are small enough to hide behind a city, and powerful enough to bend the universe. Nathan slows the Icarus 7. The closer he gets, the less ordinary distance becomes. Space is no longer an empty room around the stars. It is part of the action, stretching and twisting under their motion. The instruments do not hear a sound. They measure a pattern, a rising chirp caused by two objects orbiting faster and faster. The signal is invisible to human eyes, but the ship translates it into motion. On the console, the chirp climbs. The interval between pulses falls from seconds to fractions of a second, to something too fast for instinct. Nathan realizes that the final moments have already begun. These are not glowing balls of ordinary gas. Their surfaces are hard, compressed matter. Their magnetic fields are immense. As they approach, those fields reach across the growing gap like invisible cables. The fields connect, break, and reconnect. Plasma flashes along them. For a few milliseconds, the system becomes a laboratory more extreme than anything humanity can build on Earth. Nathan commands the ship's shields to deploy. He is not trying to stop the collision. Nothing built by humans could do that. He is trying to survive the information arriving from it. With every orbit, the stars lose energy to gravitational waves. The dance tightens. Their shapes stretch under each other's tidal pull, as if gravity itself is trying to draw both objects into one. From far away, the stars would seem to move almost normally. From Nathan's viewpoint, the geometry around them is changing. Light bends, clocks disagree. The clean lines of navigation become uncertain. The flight computer marks the final orbit. It is not a countdown to an explosion in the ordinary sense. It is a countdown to a new object, formed in less time than a camera shutter can open. Nathan says nothing. He watches two stellar courses approach the end of separate histories. In the silence, their gravity writes the last line of the old story. Then they touch. Not with a simple flash, but with a violent deformation. Matter is torn, squeezed, and thrown outward. The collision becomes a whirlpool of nuclear density and impossible heat. For a fraction of a second, the merged core may resist its own weight. Around it, a disk of debris spins at incredible speed. The center is hidden inside a storm of radiation, magnetic fields, and gravity. Above and below the merger, Magnetic fields can organize the debris into narrow jets. If one points toward Nathan, the sky ahead will not merely brighten, it will become a beam of high-energy light. The ship turns. Nathan does not know whether the jet will miss by 1,000 kilometers or by 1,000,000. In space, survival can depend on an angle smaller than a thought. The first flash is gamma radiation, the most energetic light in the electromagnetic spectrum. It arrives before the softer glow, sharp and brief, carrying news from the instant of impact. Icarus 7's outer systems flare with warnings. The shielding absorbs what it can. The ship's cameras close. For several seconds, Nathan sees the collision only through instruments. The data arrives in 2 languages. One is light, the other is gravity. Together, they reveal something remarkable. The universe is not only showing us an event, it is letting us measure it. As the debris expands, it cools and glows. Astronomers call this afterlight a kilonova. It may shine across visible and infrared wavelengths, changing color as different layers reveal themselves. Inside that expanding cloud, neutrons can help build some of the universe's heaviest elements: gold, platinum, materials that one day may become part of worlds, machines, and memories. Nathan looks at a small metal ring attached to his console. He knows that the atoms in it were forged in ancient stellar violence. The collision is distant, but its history is already inside the human story. The ship drifts behind the expanding plume. Debris continues outward. Some moves at a significant fraction of light speed. Some spreads into a broad, glowing shell. What remains at the center depends on mass, spin, and the unknown behavior of matter at extreme density. The remnant may briefly remain a heavier neutron star, or it may collapse into a black hole. If a black hole forms, it does not vacuum up the entire galaxy. That is a common myth. From far away, gravity behaves according to mass and distance. The danger is local, not universal. The galaxy does not shatter. Nearby planets are not automatically ripped apart. A stellar collision is catastrophic at its source, yet the universe around it remains astonishingly large. Nathan sends the first report. He includes the waveform, the light curve, the jet angle, and the changing colors of the kilonova. Inflow measurement will help scientists understand how space, matter, and time behave together. The message begins its long journey. Even traveling at light speed, it will take years to cross the distance between Nathan and home. His skull is emitting, but Nathan is not. For the first time, Nathan understands the loneliness of witnessing something no one else has seen yet. The future will know the event, but for now, it belongs to him and the instruments of Icarus 7. Days pass in the ship's clock. The brightest light fades. The colors shift. The debris becomes thinner, colder, and more transparent, while the gravitational signal continues outward through the galaxy. The collision has created no permanent doorway and no magical new sun. It has created something more useful, a natural experiment, recorded across many channels, allowing different observatories to compare the same cosmic moment. Telescopes read the light. Radio dishes follow the fading afterglow. Space observatories watch the high-energy sky. Gravitational wave detectors measure the shape of the passing ripple. On Earth, the change may be smaller than the width of a proton, yet careful instruments can detect it. A wave from a collision far away can move mirrors, alter data, and expand human knowledge. Nathan records one final personal note. He says the collision did not look like two stars smashing into one another. It looked like the universe changing its mind about where one object ended and another began. That may be the deepest lesson. In extreme gravity, separation is temporary. Two histories can merge, release energy, forge elements, and leave behind a remnant with a completely new identity. And yet, from a distance, it becomes only one more point of light. The universe can be violent without being loud, enormous without being obvious, and ancient without ever standing still. Somewhere far away, Earth continues its ordinary day. People wake, travel, argue, laugh, and look at the sky without knowing that a new source of gold may be expanding through space. The atoms forged in distant mergers may become part of ordinary objects. The spectacular and the familiar are connected by chemistry, time, and the long recycling of stars. Nathan turns the Icarus 7 toward home. Behind him, the remnant fades into darkness. Ahead, the mission is no longer about reaching the collision. It is about carrying its meaning back. So what if two stars collide? The answer is not simply an explosion. It is a chain reaction across physics. Gravity waves, compressed matter, high-energy light, heavy elements, and a remnant we may never see directly. It is a death, a birth, and a message at the same time. The stars disappear as separate objects, but their final moments travel outward, teaching every observer who can catch the signal. Nathan watches the stars. He whispers the only words that feel large enough. We are made of the aftermath. Then he closes the observation log, and the Icarus 7 slips into the dark. The universe keeps moving. Somewhere, two more stars circle. Somewhere, another signal is beginning. And somewhere, another traveler may be watching the darkness become light. This is Mind Astray. Keep looking up, because every star has a story.